All right. So we're here for advanced VPC design and new capabilities for Amazon VPC. I thought about giving this one a new name this year. It's kind of clunky to say, but I figured I'd keep it. This is actually a repeat of last year, and we go into Amazon VPC design, and we talk about all of the new features and all of the changes or architectural decisions that you'll make based on these new features. I've got a bunch of slides here for you today. But first, I've got a little housekeeping or a couple of housekeeping items. So 4.9, last year, it was around this time, I think it was a Thursday or it might have been a Wednesday, I actually said that if I didn't get a reasonable customer satisfaction score in my session, I probably wouldn't be allowed back at reInvent. Well, you guys are amazing, and you gave me 4.9 out of 5, so that's unheard of for any of the breakout sessions. So first, thank you. Thanks a lot. Really do appreciate it. Now, I have taken a lot of the feedback to heart. So when you do fill out an evaluation, you'll type in a little phrase. I did say feel free to throw any jokes in there. There was a couple of good ones. There was a couple of questions too. So like 3 people asked me, how old are you? Well, I'm 35. There you go. I don't know why you want to know how old I am, but a couple of people asked that. So there you have it, in 1983. Also, a few people asked how many animations were in my presentation last year. And I was like, man, a lot. I don't want to sit down and count them. But then I got to thinking, I'm like, man, I kind of want to find out now. So I sat down and opened up an Excel spreadsheet and had a look at all the animations. And there was 336 animations in the presentation last year. So it's quite a lot. Now, when we're talking about a VPC architecture, it starts with the VPC. And the VPC is just kind of a square box on a PowerPoint. But when you start adding things, and especially with new services, it gets really, really complex. And I like to do build outside. So no difference this year. I've actually got 402 animations. Now, I don't know how much we can trust that number, because I kind of did inflate the number a little bit just to get it above 400, because I wanted to kind of break that barrier. It was like 396 or something. I needed to add a couple more to get over 400. Now, if I do get a decent customer satisfaction score this year, 5s are great, but mark me honestly and put some jokes and some feedback and some questions in the feedback. I read every single piece of feedback you guys post. I'll try and make it to 500 animations next year if I come back. How about that? Now, this is just a reminder slide for me, but it's adorable, so I couldn't not put it in there. This is a disclaimer that it's a 300 level session. And we're not all created equal. I mean, we're at different areas of our journey to AWS. And a 300 level session is kind of one of those weird areas where you can dive really deep and get into 400 and even 500 level content. But then there's a lot of people in the room that are only at 100 or 200 level content. So we're not all propeller heads like these folks. And we will bounce around a little bit. So have patience with me. We've got a bunch of build outs. We're going to dive pretty deeply in some services. But we're going to gloss over a couple of others and just kind of do a sprinkling and give you guys an idea. Now, a piece of feedback I did get last year from a lot of people was, how do I find out more information? Where do I go? What do I do? I mean, I just drop a bunch of service names and you forget about it and we go from there. I've actually made a point to put a lot of small links in the presentation this year. So feel free to have your phones out and take a photo, or these slides will be on SlideShare, and this session will be up on YouTube as well. So. That said, let's have a look at 12 months ago, how we would build a VPC architecture. So previously from AWS, you've /got Amazon EC2, you've got an Amazon region, a VPC. A VPC is a region level construct. We've got a CIDR address range, so a 10/16. You can expand that CIDR range, so you can add additional ranges to that VPC now. This is last year, 12 months ago. We had IPv6 support, awesome. We've got some availability zones, some public subnets, some private subnets. This is pretty standard stuff. This is, 101 stuff. Now, you will notice some of the animations fade in and fade out just to add some emphasis. Otherwise, it just looks like a dog's breakfast. But we've got some instances here, A, B, C, and D. They're sitting inside subnets which are tied to the availability zones. And then we have a route table. We have a route table for, in this case, the subnet that instance A resides in. And in that, we have what's called the local router, 10.1.0.0/16. So that tells every instance how to get to every other instance inside the VPC. Now, you can't actually change that route right now. That's something that we set. So we give all of your instances connectivity, and then you lock things down with security groups. If we look at our private subnet, and I've separated these two into private and public, we've got the local route as well. But what if we want to talk to the internet? Or a lot of services that sit in the public realm, like DynamoDB, S3, SQS, SNS, all of those, and we'll talk about how to get to those privately. But communicating publicly, we've got an IGW, and then we add a route to an IGW. Again, this is your 100, 150 level topics. We've got an elastic IP, and we'll talk about elastic IPs coming up. But the elastic IP sits at the IGW. We can route to public services and the internet. Great, sounds good. Now, our default route within instance C's subnet points to a NAT instance. Or, I hope, you're using NAT gateway because it's much easier to manage. So now we have a default route to the NAT gateway. We add a VPC endpoint so we can talk to S3 and DynamoDB, for example. You'll notice we've got additional routes there for the prefix lists, for S3 in this case. We've got a VGW, and I know the text gets really small here. I was really trying to pack it all in. We've got an on-premises, a VGW, a VPN, Direct Connect, which connects to a VGW as well. We're using Direct Connect Gateway 2. We've got an on-premises route via a VGW for both of our subnets there. Then we add in some peering, inter-region or intra-region. So last year we launched inter-region peering. That was one of our big announcements. Pretty cool stuff. We've got some routes there. Last year we also had VPC flow logs going to CloudWatch. We'll discuss that a little bit as well. And also PrivateLink. So PrivateLink, and you as a service provider can build a VPC and drop a private link into a customer or consumer's VPC. We also have this ongoing effort, and we launched this last year, where we can have public services like the AWS EC2 API and Kinesis Streams and some others accessible privately inside your VPC. So there's this trend for us, or AWS, and we're looking at services that you would traditionally access publicly through an IGW, and how can we bring those into the VPC so we can access them privately? Because a lot of customers have really taken VPC and ran with that as, that's my domain, that's my private domain, that's what it was designed for. But then we used to tell them, oh, well, if you want to access S3, you've got to go through an IGW. With things like endpoints, you don't have to do that now. Right, so that was 12 months ago. Now, I wanted to add a little bit of contrast here into my next presentations, so I try to dazzle it up a little bit, but we'll see. I actually forgot to put a color in the first presentation, first slide. We'll have a look at that. But the first thing we have been launching over the last 12 months are additional endpoints for PrivateLink. So this is a slide from last year. You'll notice our icons have changed. We've got this new kind of blue, or it's actually called squid ink. It's kind of cool. It doesn't work too well on a gray background, but this is last year's slide. So actually this turns into before, where we had our gateway endpoints, or our VPC endpoints via the gateway mechanism. We had our interface endpoints, which we'd drop inside a subnet. Now you don't need a route or anything to connect to those. They basically take up think of it like an elastic network interface or an address inside your VPC, and you can now talk to the EC2 API endpoint, etc. So no route table updates required, unlike S3 and DynamoDB. Now what we've been busy doing is visiting all of the services that we feel we need to connect privately into the VPC and adding this functionality. So now we have 18 services as of, I think that was last week. I think it's still current today. If you count how many are on there, there's actually 17, but I had to put a plus more just in case more launched. But basically, we have 18 services now through PrivateLink, which is pretty awesome stuff. So if you want to learn more about PrivateLink or interface endpoints, here's one of those links for you. So feel free to take a photo. Like I said, slides will be available. I had to get my animation count up somehow. Now, when we did launch PrivateLink, we didn't have access for PrivateLink endpoints over VPN and inter-region peering when we launched inter-region peering. So recently, we've upgraded that. We've filled in that capability gap, and that's now available as well, which is pretty cool. This is a new one. This is brand new. The next one here I've got is Amazon VPC sharing. Was anyone in the Dave Brown session just recently? A couple of hands, okay, yeah. So we just announced VPC sharing, like 2 hours ago. So it's like brand new. It's pretty awesome. I don't have a lot of content on this, but let's dive in there and see what I've got. Okay, so before VPC sharing, what would you do? Let's just say you had a couple of accounts. You've got some dev, some tests, prod 1, 2, 3, and 4. And inside those accounts, we've got our VPCs, Barry and Sue, our two devs. And then we've got some other VPCs, Pegasus, Llama, Iguana, Steve. I was kind of running out of names. There's probably like 50 Steves in the room here. Sorry, Steve. Inside those VPCs, we've got some Amazon EC2, maybe some RDS, some Redshift, maybe some Lambda. And these are all deployed in VPCs inside their own accounts. Now, we're using separate accounts in these cases for, I mean, it's a demarcation point, and we'll talk a little bit more about that. But then if we want to connect these VPCs together, we'd use VPC peering. So Barry wants to talk to Sue, or rather Barry's EC2 instances wants to talk to Sue's EC2 instance. You'd set up a peering connection. You'd configure a route and connect the two VPCs together. What happens after VPC sharing? What does this actually look like? Well, first up, we don't need VPC peering connections. That's pretty huge. So what happens is, we actually, using our resource access manager, I think it's called, and I'm pretty new to that as well, but we've got Barry and Sue now sharing a VPC together. Pegasus, Llama, Steve, and Iguana also share a VPC. So what does that mean? Well, we've got a subnet that spans multiple accounts. The VPC basically spans multiple accounts. So the Pegasus subnet 10.2/16 also exists or is accessible via Steve, Iguana, and Llama. Say that 10 times fast. Okay. So there's this concept that we had to make called an owner and a participant. Now stand by for a wall of text. Oh, the next one's worse. So an Amazon VPC owner is responsible for creating and managing the VPC itself. So think of like the route tables, the VGWs, all of the VPC constructs. That's the VPC owner. VPC owners can't delete participant resources. That'll be important in a second. Here's the wall of text. So an Amazon VPC participant will share the VPC with the owner, but they can't modify the VPC constructs. However, what they can do is they can spin up resources effectively in that subnet. Okay, so why would you use multiple accounts? Well, again, what if you had a different billing organization, or what if you wanted that demarcation between you've got Barry's organization and Sue's organization, and you have separate accounts, and you'd like to have two separate VPCs, but you really want them to talk to each other. Now with VPC sharing, you can do that. Now, one key point I didn't mention is all of these VPCs do need to be part of the same AWS organization. So why would you use VPC sharing? Well, now you've got a subnet that is shared amongst multiple accounts. So you can reduce IPv4 CEDA address spacing. Did I say that right, CEDA? I think that's right. Interconnectivity, you don't need VPC peering anymore. These resources can talk to each other. So the participant can spin up an EC2 instance that can talk to an owner's Redshift cluster, for example. Separation of duties, that sounds pretty straightforward. So you could have a central team managing your VPC and have other teams spinning up resources inside that centralized VPC. And billing and security. So you can enjoy segregation with multiple accounts. Now here's a good one I added in. Same AZ cost for data transfer is nil. So with peering, if you're in the same availability zone, you've got to pay for peering. With VPC sharing, you don't. That's pretty huge. Okay, there's a link there if you'd like to know more about VPC sharing. We've got a bunch of docs that are live. I actually did do a search about an hour ago, and they are live. So you can check it out now. VPC sharing is available, and yeah, jump in there and check it out. All right, global accelerator. I really love our Route 53 team. They're always really quick to respond and jump into customer calls and everything, and they take their customer feedback at heart, like all of us do at Amazon. And we were getting feedback to build a particular use case with Route 53, and I'll talk about it in just a second. But before Global Accelerator, and you're wondering, what's Global Accelerator? We'll get there. So let's just say you've got 2 VPCs. They're in 2 different regions. You've got an NLB, you've got some instances in each of those regions. Great. You've got an internet gateway on both of those VPCs. You've got some public IP addresses at the internet gateway. Again, that's a static one-to-one NAT from a private IP to a public IP. We'll talk about that a little bit later as well. And then if you wanted to do some form of redundancy or load balancing across the 2 regions, you can use Route 53. So in this case, we've got example.com, really straightforward example. And we've got 2 A records that are being responded to or being handed back when someone does a DNS query on example.com. So that's going to send users down to these 2 sites. And we have a whole bunch of mechanisms where you can do a form of DNS load balancing and that sort of thing with Route 53. You can do geolocation and a whole bunch of other stuff. So that's with using DNS. Now with AWS Global Accelerator, what we've basically done is we're taking CloudFront, so our edge locations, and we now have a single IP or an Anycast IP, there's the keyword Anycast, sitting at the CloudFront edge. So in this case, we've got all of our CloudFront POPs, and I don't even know how many there are now. I think there's over 100. And this IP address could be advertised out of, not all of them at GA, but we've got a single IP advertised out of many CloudFront edge locations. So what happens here is users will hit that IP or request something from that IP. They get routed to the local CloudFront edge location. Then they go over the AWS backbone, and then they'll hit an NLB and your application. But the front-facing IP or Anycast IP is a single IP. It's shared across regions. Elastic IPs have traditionally been in AWS a region-level construct. Now we've got an IP that you can use and Anycast out of a CloudFront edge location. Pretty cool. So a couple of points here. Going from the edge locations back into AWS, you would be using our global network. Our global network's pretty awesome. If you've seen any of the James Hamilton talks, you'll realize that how the scale and the awesomeness that goes into when we build our AWS backbone. Highly recommend watching some of his talks. Still relevant today. Client state as well. So applications can keep state with the connections after they're routed to the same endpoint, after the initial connection. And these are basically static Anycast IPs that will sit at the CloudFront edge. Pretty cool stuff. So that's Global Accelerator. So really, Global Accelerator helps with a multi-region approach. So your traditional architectures where you're using DNS for a multi-region architecture, you could now use AWS Global Accelerator. And as you've seen, it's pretty straightforward. Now, as I said, I really love the Amazon Route 53 team. They decided to give us a bonus feature here. This has been something that's been requested for a long time. I don't actually have a slide on this one yet, but I need to build one. I'm still thinking about it. But we did release a white paper about 12 months ago that shows you how to use Route 53 in a hybrid environment. And Route 53 endpoints or private hosted zones and the like aren't accessible over a DX or a VPN. So what you would need to do is build a resolver on an EC2 instance, or I think there was a bit of a hack that you could do with SimpleDB back in the day as well. But now we're basically offering a Route 53 resolver that is reachable. So it's basically a resolver service for hybrid cloud environments. Definitely worth checking out as well. All right. So we've had 3 or 4 now, back-to-back, hot off the press services that we've actually just announced. So as you can tell by the name of this one, AWS Client VPN, we now have a service that allows you to do that. Let's have a look at what managed VPN looks like in AWS before AWS Client VPN. So we've got a VPC. We've got a VGW, we've got your on-premises. And you basically build an IPsec tunnel from your on-premises CPE, or we call it a CGW, but that's really just a fancy name for a customer premise device. And you would build an IPsec tunnel to the VGW. So there's 3 components there if you wanted to build an IPsec tunnel and use AWS Managed VPN. The VGW could be replaced with an instance if you wanted to, and lots of customers do that. They deploy an instance in AWS. And in fact, we have a lot of requests from customers to say, we'd like to have a client or client-to-site VPN to AWS. This architecture here, or this feature, I guess you could call it, is site-to-site VPN using IPsec. Customers want to use things like TLS or OpenVPN and have a client on maybe a laptop, for example, and connect into AWS. And that's actually not supported with the virtual private gateway. So that was before AWS Client VPN. So all of our managed VPN connections were site-to-site VPN connections. So how does client-to-site change your architecture? Well, we now have client-to-site VPN. Awesome, pretty straightforward. It's okay, I've got a slide. Hold on. All right. So we have a VPC, and now we have this client VPN endpoint, which you connect to. So you've got a user with an OpenVPN client or something similar. You can then connect to the client VPN endpoint, and you can attach the client VPN endpoint to a VPC. So if we just have a look at this, you've got a user, OpenVPN, a TLS-based tunnel over the internet. So it's not IPsec now, it's TLS. And then the attachment to the VPC. Now, we'll talk a little bit more about attachments to VPCs, and when we get to Transit Gateway, that is in this session as well. I'm actually saving a lot of time for that because we dive pretty deep on that. But the attachment here to the VPC basically takes an interface in the VPC. So you think of like an EC2 instance that has an Elastic Network interface and it has an IP address inside that VPC. Same story here. So the client VPN endpoint is going to be taking like an ENI in, or the attachment will take an IP inside the VPC. Now what that allows you to do is connect to other VPCs, because it looks like your client VPN endpoint exists inside your VPN. Inside your VPC. We love 3-letter acronyms here, as you can tell. So you can connect through to another VPC via peering. You could connect to public services via an internet gateway. You could also connect to your on-premises via a direct connect. Pretty awesome stuff. So now you can have client-to-site VPN connecting to an attachment to a VPC and connect to your environment from there. We do have a session on client VPN, and I was going to throw session IDs in here, but most of the sessions have been loaded earlier in the week. But this one is actually on Friday, so I'd highly recommend going along and checking it out. And Karthik is one of the service owners. He's going to be there with Tom, one of our other solution architects. Okay, so we've talked a little bit about elastic IPs and where they sit at an IGW. And an elastic IP is a single IP address that we give to you to use and attach to your instances, or allocate to your instances. Now, what if you wanted to bring your own IP range? We've had a lot of customers that have their own IP range, and they'd love to bring those into AWS. So about a month ago, we launched Bring Your Own IP. So firstly, where do you use public IPs in AWS? Well, we've seen them sprinkled throughout the architectures that we've seen so far, but really, an elastic IP sits at the IGW, and it's a static one-to-one NAT from a private IP to the public IP, from one of Amazon's IPs. Now, if someone looks up your IP, the Amazon Elastic IP on the internet, in one of the many databases, they would see that it's allocated to Amazon. Why would you want to bring your own? Why not just use Amazon's? Well, there's a couple of reasons. So traditional data center folks will probably have a /24 or probably larger site address range that they want to use. And over the years, they've been building up this reputation. So there are services out on the internet that will look at different IPs and the type of traffic that's coming from those IPs and then rate those IPs. These are services that you can subscribe to. And if you do a lot of spamming with an IP, you could get a poor reputation. Or you could build up a decent reputation with a set of IPs that you use. You might also have sites out on the internet that are whitelisted to the exact IP. Now, we always say you should use DNS, and DNS is great, and you shouldn't reference a specific IP directly because it's hard to change. I mean, imagine if you had a bunch of IT devices out there that were hard-coded to only be allowed to talk to a specific Amazon Elastic IP. Now, what if you started auto-scaling, or what if you decided to change that IP? What if you already have that configured in your on-premises environment and you want to bring that same IP into AWS? We also have migration. So a lot of customers say, hey, I've got this public IP range. I'd love to come and use the cloud, but I really need to use this IP range. I can't change it. So you can now migrate and use that same IP. Also redundancy. And we'll talk about this in just a second. But you can advertise the Amazon or your brought IP range out of Amazon and have it advertised out of your on-premises. Now, you want to make sure you know BGP and you basically have network engineers that can help you out if you're not a network engineer yourself, but you could potentially do that. Now, we probably recommend using one or the other, so advertising the IP range out of Amazon, and then if you wanted to fail over, you could fail over to an on-premise or something like that. There's a lot of different arrangements that you could do. So how does bring your own IP work? It's reasonably straightforward. So you've got an on-premises, and we've got an old school CPE over there connected to the internet, and we've got this range here, 130, 137, 182/24. It doesn't really look too familiar to me from an Amazon perspective. Most of our site address ranges are 54, and I think there's even some 3s now, which is pretty awesome. But then you decide to build at AWS, and you've got a VPC and you want to bring that range over. There's a couple of steps you need to do. So we need authentication and whatnot to bring the IP across. I'll talk about that. But once you do bring the IP to AWS, it turns into what's called an IP pool. So this is a new concept in AWS where you've got a /24 you've brought to AWS, and now you have a pool of IPs that you can use for your services. So you can advertise that out to the public internet, or you can remove the advertisement. And then when you spin up things like EC2 or a network load balancer, which can use an Elastic IP, or a NAT gateway, for example, you can allocate these IPs to these services. And you'll notice here we're using a 130.137.4.5 and .6 because you choose what IPs out of that range that you want to allocate. So there's a couple of steps to bring your own IP to AWS. The first is, well, there's a lot of steps, but the first is authorization and authentication. There's 5 steps involved there. I've got a link, check it out. It's actually pretty complex. I didn't want to kind of muddy the slides here with a lot of stuff because you basically need to prove that you own these IP ranges. It's not too bad. It's actually pretty easy. I got given an IP range a week ago to kind of test this out, and it took all of a day to bring the IP into AWS. We do checks to make sure that the IP is yours and also that it has a decent reputation as well. So that does take a little bit of time, maybe 8 hours or whatnot. So once you've done the authorization and authentication steps, you want to provision your IP range. Now this is through the Amazon CLI. That's part of the checks that we do, and we make sure everything looks good. So authorization and authentication, then provisioning. Then you select to advertise your range. This is again through the Amazon CLI. So you basically designate that IP range and say, hey, Amazon, I want you to advertise that out to the internet. Now, bringing your own IP, as I said earlier, Elastic IPs are a region-level construct, just like a VPC, and the site or address range you bring to AWS is also a region-level construct. So you choose the region, and then you advertise that out through that region. You can also simultaneously create Elastic IPs from your IP pool and start using them. I've got a couple of console screens here. It's pretty small, but just to demonstrate the differences here. So if we jump in here and say allocate a new Elastic IP address, you'll notice that we now have this owned by me tab. If we click on that, if you have an IP pool that you own, you'll notice there's another drop-down box here. You could have many IP ranges that you've brought to AWS, but you can select the IP range that you want to allocate a Elastic IP out of. You can also select an address. So you could say, just pick a random address out of this range, that's fine. Or I want a specific address. I want a 130.137.182.166. Once you allocate that, really straightforward. You'll notice here at the top here, we've now got that elastic IP that we can use that's out of the range that we own. Now with elastic IPs, there is a charge if you allocate them to your account and don't use them. With bring your own IP, they're your IPs, so it's free. You can just bring them to AWS and use them. The pool can sit there and you can use them or not use them. You actually own these IPs still. You can deprovision them and take them back. You can re-provision them in another region if you like as well. Those are real IPs in my account, so please no one DDoS me. Okay, some detailed instructions. I did promise a link here, so check it out. The 5 steps are where you really want to read carefully, but follow that link and all will be described. Okay. So what's the most specific prefix I can bring to AWS? Well, it's /24. We can't go any smaller than that. Can I move aside a range between regions? Yes, but you do need to deprovision and reprovision in another region. This is a common question I get. IPv6? Not yet. Okay, so before, public IPs were basically allocated out of AWS's ranges. After, they're allocated out of your IP pool. Great. So I've done a couple of chalk talks this week. I think I've done 3 so far. I've got another 3 to go. There have been a lot of questions about Transit Gateway. This is something that we launched on Monday, I think it was. And it's basically a new construct in AWS. So we've got an IGW, a VGW, so an internet gateway, a virtual private gateway, and now we have a transit gateway, so a third type. We're going to dive in here, and this is where we get into the weeds a little bit around what transit gateway is and how it works. So transit gateway, or what I'm going to refer to as the TGW from here on out. So before transit gateway, what do things look like? Well, we've got a VPC, or 3, and we'd like to connect these 3 together. Great. We spin up 3 VPC peering connections. And I'm focusing on B here. I'm going to pick on B. We've got peering connection 1 and peering connection 2. We then have a route table that's allocated to a subnet, and for each one of these connections, we do need to specify a route. So we say in this case A, or CIDR range A, is via PCX or peering connection 1. CIDR range C is via PCX connection 2. Pretty straightforward. We do the same thing on A and C. Now all our VPCs can talk to each other. Now as you add additional VPCs, you can see it gets pretty complex. We're adding a lot of ranges. Now VPC peering has been great. Before VPC peering, a lot of the architectures for VPC to VPC connectivity were via IPsec instances. So our customers were spinning up instances and connecting IPsec between the instances and doing things that way. Or having a VGW on one side and an instance on the other side. So peering in that regard is fantastic. If you just want straight up connectivity between 2 VPCs or a couple of VPCs, peering is probably the way to go. So with a full mesh, how many VPC peering connections do I need? Let's say every single VPC that I spin up, I want to connect to every other VPC. Now you might not necessarily do it that way. You might have a hub and spoke and have some centralized resources in a central VPC and peer to every other VPC. Or you might say, you know what? I want to connect all my VPCs together and have, there was a term thrown out a while ago, it kind of didn't catch on, called a VAN, a VPC area network. Kind of funny and interesting, but. Okay, so it is an n to the n minus 1 over 2 problem. And if we have 10 VPCs, we plug those numbers in, and we need 45 VPC peering connections for 10 VPCs in a full mesh arrangement. So we need to manage 45 peering connections. If we have 100 VPCs, we need to manage 4,500 VPC peering connections. Now, mind you, there are some limits here. Each route table within a VPC can handle 100 routes. Each peering connection needs a route. You can have 125 peering connections per VPC as well. Now the route limit, the 100 prefix route limit, is actually a hard limit. We can't go beyond that. So what we did start seeing was this thing, Transit VPC. And if you check out the session catalog, Nick Matthews is actually doing a session on Transit VPC. He dives pretty deeply into these architectures and also Transit Gateway, which we're going to get to in just a second. But customers started saying, okay, well, instead of using peering, I want to have some kind of device there, and I want to use IPsec and connect to the VGW, and we're building a hub and spoke type arrangement. You might have an on-premise connected to this thing. Oh, this works great. Best pointer I've ever seen. So we have a centralized VPC. You might have direct connect to that VPC. Or you might have VPN connected to that VPC. So now you've got a centralized VPC, which is then connected out to these other VPCs in a transit VPC type arrangement. If you did want to connect from your on-premises to AWS via VPN, as of Monday morning this week, before Transit Gateway, you would need to build a VGW per VPC. So you'd have to have this. Every single VPC that you spun up on premises, you'd have to configure the IPsec tunnel. It used to be the same thing with Direct Connect. You'd have to configure a private virtual interface per VGW until Direct Connect Gateway came along, which was fantastic. Now, Direct Connect Gateway scales to a certain degree, and it's still something you should be using. But with VPN, you needed to build a lot of IPsec tunnels on your on-premises. So what's Transit Gateway? Or the TGW? How does that come into the picture? How does that change your architecture? Well, we've got our trusty VPCs, A, B, and C. I really did run out of names. I started just using letters. And we've got an on-premises. And we build what's called an attachment. Now, the attachment is going to be something that is configured on the TGW and attaches to a VPC or a VPN. So we've got attachments 1, 2, 3, and 4 here. Within the route table of VPC-B, we have to obviously have a route to the TGW. I've just chosen a default route here. Now, within the TGW, we have a route table that we can manage. So the TGW here, you can see we've got VPC A, B, C, and on premises inside the route table. So VPC A is via attachment A. On-prem is via VPN 4. So we've got a routing table there. Or tables. You can actually split that out into multiple route tables. So that in this case, VPC A and VPC B can talk to each other because they're in the same route table, and we'll get to propagations and some other functionality that we have in a sec. But on-premises can only talk to VPC C, so we've got those in 2 separate route tables. So let's define some terms here a little deeper. So an attachment. An attachment is really the connection from an Amazon VPC to a VPN or a TGW. So you've got the VPC or a VPN and you attach to the TGW. Great. Association, what's that? I haven't heard of that before. Okay, an association is a route table used to route packets from an attachment to an AWS VPC or VPN. So you've got an attachment, a packet that comes in over that attachment is associated with a route table. As the packet comes in, we have a look at the association, and we say, okay, this is associated with route table 1. We're going to use route table 1 to route that packet. So the association is the attachment to the route table. A propagation is a route table where the attachment's routes are installed. So if we have an attachment that has a VPC with a CIDR of 10.1/8, and we're advertising that into the TGW, the propagation, if we say have attachment A, B, and C in a route table A, B, and C, we'll install those routes for that attachment. We'll explain it just a second. I've got a really complicated diagram for you, but we're going to step through it step by step. Okay, so in this example, we've got a TGW, and we have a single route table, just a flat route table, just like what a VGW kind of looks like, except now you can manage the routes in here. And we have VPC Llama again. We have an attachment from the TGW to VPC Llama, and we're going to call that attachment X. We then have an association. So Llama from X, packets from Llama are associated with route table 1. Propagation, we're taking the CIDR address range, the 10.100/16, and we're propagating it or installing it into route table 1. So then our routes get populated in route table 1 to say we've got 10.1/16 via X. So anyone in that route table can now route to Llama. If we add Pegasus, again, attachment Y, Pegasus from Y, so packets from Pegasus will go into the route table and get routed accordingly. We've got propagation, so we're installing the routes from Pegasus Y. And now we've got the 10.2 CIDR address range from Pegasus VPC. Third, Barry. Get on Barry. We've got attachment Z, Barry from Z, and we're installing the route 10.3. So with this flat route table, now all of these VPCs can talk to each other because we have a route table where we've enabled the propagation for all of the CIDR address ranges to be advertised and installed into that into that route table. And each of the associations for those attachments are in that route table. So a packet comes from Llama, it goes into the route table, we have a look up, the destination is Pegasus, we route it out the attachment for Pegasus. So now you've got it's almost like a hub and spoke type arrangement where the TGW is the hub. So if we look at the route table here, we've got a default route via the TGW. What if Barry, for example, has an IGW? What do? It's very similar to when you had a VGW. You'd actually have a route table, and you'd have a default via the IGW, but then a specific route via the TGW. So all packets are going to go from Barry into the TGW destined for the 10/8 range. Okay. Let's add some additional CIDR address ranges inside Llama. As we can do expand VPC. So we've added a 10.8 and a 10.9. What happens? Well, we have propagation turned on, so those routes get propagated into the route table of the TGW. We don't actually propagate, and this is why I was talking about configuring the route or configuring the route on the VPC side. We don't propagate from the TGW to the VPC, just in the fact that the TGW can support many routes and the VPC can only support 100 routes. So in this case, we've actually got propagation from the VPC into the route table of the TGW. You can turn off route propagation from the VPC into the TGW if you wanted to. Why would you want to do that? What if you had some overlapping CIDR address ranges? So we remove propagations from Llama. The routes for Llama disappear. We now can't connect to Llama. But what you can do is manually go in and statically configure those routes and say via X. So now traffic would go to Llama. Now, if 10.9 was an overlapping CIDR address range with our on-premises or with another VPC, with an EKS pod address range, something like that, you could remove that specific route. Now you're only sending packets for 10.1 and 10.8 down attachment X to Llama. So you get some policy control with the TGW that you didn't have previously. On a VGW, you don't even see the routes inside the VGW. You just turn on route propagation on a route table or not. Okay, this is where it gets a little scary. So we've got, you notice I expanded the box there quite large. We've got the route tables in the TGW. We'd like to have Llama and Pegasus in one route table. We'd like them to talk to each other. Barry, we're going to isolate Barry in his own route table. Route table 2. Now we've got an on-premises via a VPN. Attachment Q, route table 3. So we've got 3 route tables. Yes, I'm going to fill all these out. Let's step through it. So we have Llama from X, the association in route table 1, and we have the route for 10.1. We have Pegasus from attachment Y. We're propagating from Y. We have the 10.2. We're also propagating from on-prem Q. Notice there's no association there. So route table 1 is not going to be used to route packets from on-premises, but we are installing a destination or a route. Anything that's propagated from on-premises is going to be put in the route table RT1. On-premises is actually associated with route table 3 in this case, and we're propagating, so it's got that on-premises route, the 172.16 CIDR as well. We're also installing Llama from X. So we're installing the route to go to Llama. We're installing Pegasus from Y. You'll notice Llama and Pegasus can now talk to the on-premises even though they're in separate route tables because we are propagating those routes. Barry, well, he's in his own route table 2. And we're going to say, Barry, okay, you can talk to on-premises as well, but you're not allowed to talk to Llama or Pegasus. We've separated those route tables. Okay. So we've installed Barry's route in Route Table 3 as well. So let's look at a packet as it comes from Llama. What happens? The packet gets sent out the attachment because we had a route in the route table of Llama that sends traffic to the TGW, which is destined towards the 172.16. Then there's a lookup. We say, okay, Llama is attached to, associated with route table 1. Great. Where our destination is the 172.16, which is actually your on-prem from Q, which means we've got a destination for 172.16 or on-prem in the route table via attachment Q. So the TGW does this lookup based on the route table and then says, okay, that's easy. I'm going to send things out via attachment Q. And the packet goes on its way and goes to your on-premises. That's basically how the route table lookup works. Now, if we send a packet from Barry, and it's also destined for your on-premises, Barry is associated with route table 2. So now we're using route table 2 to look up where the packet should be going. We've also got the on-premises routes installed in Barry's route table 2. So we have a destination of 172.16, which the destination of the packet is, and that's via attachment Q as well over the VPN. Great, let's send that packet on its way too. So you can see that attachments, propagations, and the routes inside the route table are all configurable by you. Now, as you can see here, we've just got a simple scenario where we've got 3 VPCs and 1 VPN connection. But you can see you'll be adding additional route tables and you've got the full policy control there for what the TGW can do. Really quickly, just because I want to show you folks what the console looks like. If we wanted to create a transit gateway, this is under VPC. You'll notice on the left-hand side now, and everyone should see this in their console today, there's transit gateways, transit gateway attachments, and transit gateway route tables. So this is where you could configure the transit gateway. You can also use the AWS or Amazon CLI as well. But if we just go up to create a transit gateway, we enter a name for our transit gateway. We're creating a transit gateway right now. We're going to call it Unicorn TGW, and description, the TGW is awesome. There's a bunch of configuration options here. The first one is the autonomous system number. So I've got a bunch of tabs there where we can see the description of these, but feel free to jump into the console later and check it out. DNS support. The one I really want to call out is ECMP. The TGW now does ECMP, unlike the VGW, which doesn't do ECMP. So that's pretty awesome. Or equal cost multipath, which basically will load balance across multiple VPN connections that connect to the TGW. And we'll talk about performance in just a moment. Automatically associate the attachments with the transit gateways, default route table, cool. You turn on propagation by default, accept attachments. So yes, the TGW does work across accounts. So you do use the Resource Access Manager, I think it's called, and you can basically allow that TGW to accept connections from other accounts. So you've got a TGW in one account and a VPC in another account. They can connect to each other via an attachment across that account. All right, let's just keep going here. It's actually really, really simple to create the TGW. That's it. We've now created a TGW, Unicorn TGW. Now what we will want to do after that is jump into attachments and create the attachments to the VPCs, and then jump into route tables and manage the route table or route tables that you use. Okay, so some more numbers here. Actually, I see a star there. We'll disregard that in just a second. TGWs per account. So you can have 5 TGWs TGWs per account and TGW attachments per VPC. So a single VPC can be attached to 5 TGWs. Pretty awesome. The maximum burstable bandwidth per attachment is actually 50 gigabits per second. So if you're talking from VPC to VPC, you can burst up to 50 gig, which is pretty amazing. If you think about the VGW and VPN, that could only do 1.25 gig with a total of about 4 or just above 4 gig. Maximum bandwidth per VPN connection. If you do configure VPN connections to a TGW, the maximum bandwidth is still 1.25 gig. However, Because we do support equal cost multipath, you can configure multiple VPN connections to a single transit gateway. We will equal cost multipath across those. And if your device on premises supports equal cost multipath, you can do the same, and you can actually scale out like that. We've actually done tests up to 50 gigabits per second just on one of our internal accounts. Right? I mean, that's pretty awesome. We haven't seen that kind of scale with VPN on the VGW before. Routes per TGW. How many routes can you have? Well, in a VPC, you can have 100 routes. That was the limitation we talked about earlier. On the TGW, it's 10,000. 10,000 routes. That's amazing. It's awesome. I'm trying to get my animation count up again. Number of TGW attachments per region per account, 5,000. If you're interested in going beyond these numbers, my email's at the end of this presentation. Please send me an email. We want to talk to you. That's a lot. That's some pretty crazy scale. Wow. Okay, cross-region connectivity. So the TGW is a region-level construct. It sits within the region. If you look at a Direct Connect gateway, the Direct Connect gateway is a global construct. It sits in every account. So you could have a private virtual interface on a DX gateway and go into another region and connect a VPC to that same DX gateway. The TGW is a little bit different. It does sit within the region itself, so it's a region-level construct. Now, what about cross-region connectivity? Well, today, you could use something like a transit VPC to connect two TGWs together, et cetera, et cetera. That sounds like a capability gap to me. We are going to have what's called TGW peering coming soon, I've been told. I was trying to get a solid date for you folks, but coming soon, where you can have one TGW in one region, another TGW in another region, and peer the two together, and they'll then share prefixes. And you come in via one TGW, go across a peering connection, and then go out to the other VPC. So there will be a cross-region connectivity story. Now, whenever we launch these products, we do look at things and say, okay, well, what can we get to the customer now? And cross-region connectivity is something that we're going to be doing soon. Okay. So before the TGW, we're building these architectures where you have full mesh VPCs, you've got instance-based transit VPCs, and for VPN, you're building one VPN connection per VGW per VPC. After TGW, it's basically a centralized hub for routing within the region. So you attach a bunch of VPCs to the TGW, and VPCs can talk to VPCs. You can do some policy control there with route tables. You can talk to a VPN. Now, one thing you might be asking is, what about DX? Can we attach a direct connect to a TGW? That's coming soon too. You can do 1.25 gigabits per VPN connection with ECMP, but now you can equal cost multipath across many VPN connections. So that does help with scale as well. Multiple TGW route tables for finer tuned routing, great. 10,000 routes per TGW, awesome. 50 gig of burstable bandwidth, up to 5,000 Amazon VPC attachments. So that's the transit gateway. Thanks. I've been waiting a long time for Transit Gateway, and as one of the advocates for Transit Gateway, this was an awesome moment. Further reading, check it out. There's a bunch to read about. I actually want to talk to all of you folks during the year, and I do. I talk to customers every single week, many customers every single week, and I hear the architectures that you want to build with these constructs. Right? We've got new things you can build with now. I want to see what you guys can come up with. So we have some honorable mentions here. These were the services that I didn't build diagrams and animations for. If I had more time, I absolutely would. I love building diagrams. We did do some network performance improvements for EC2 this year. Pretty awesome. So what would happen previously is an EC2 instance inside a VPC could talk 10 gig to another EC2 instance inside that same VPC. Now, when you started communicating with something outside of the VPC over an IGW, over a VPC endpoint, over a peering connection, it would actually get limited to 5 gigabit per second. Now, what we've done recently is we've upped that limit for VPC endpoints. You can now get 25 gig. And we've also upped the limit for VPC peering connections. I don't think we're going to stop there either, especially now that we have 100 gig EC2 instances, the C5N instances. Now, I did take the feedback to heart as well last year. I went on a huge tirade about Direct Connect Gateway because I actually really like Direct Connect Gateway, and I love Direct Connect. I used to do a bunch of network engineering stuff back in the day, so that's kind of dear to my heart. But I did talk about Direct Connect a lot last time, and people said, hey man, I thought you were going to talk about VPC, not Direct Connect. So the Direct Connect product managers won't be happy that they only get an honorable mention, but I'll take them out for lunch or something. But the Direct Connect team did deploy logical redundancy over a single private virtual interface. It's in Equinix SV5 right now, and will probably be in other regions soon. But with a single Direct Connect, one of the complaints we used to hear is there's only one BGP session. And if we take down that border router for maintenance or something happens on the customer's side, the BGP session drops, you lose connectivity. With logical redundancy, you can have a single Direct Connect with multiple BGP sessions. So in case there's a maintenance event or something similar, the connection doesn't go down. That's pretty cool. The DX team also worked pretty hard at this one, jumbo frame support. For the longest time, we didn't support jumbo frames over Direct Connect. We do now. Now, we're not going to support jumbo frames over the internet anytime soon. That's just the internet. But over Direct Connect, pretty awesome. Now, lastly, flow logs can be delivered to Amazon S3. This is an honorable mention as well, just because I didn't make a diagram, but previously flow logs could go to CloudWatch. Now they can go to Amazon S3 directly. Now before I go to the next slide, because I know it always turns into mayhem and folks want to run off to the next session, I do have some AWS Network Wizard stickers up the front here. I think there's like 500 of them out there. Feel free to come up and grab one of those. I will be at the speaker meet and greet. I'll throw up the details there in just a second. Please fill out your evaluations. If you give me a funny joke or a funny comment, I'll probably include it in the session next year, so we'll wait and see. But thanks everyone for coming along and enjoy your reInvent.